Okay, let's continue. This is my second video of the presentation of the project wireless communications. Now I continue to talk about the evaluation. There are three parts in the evaluation section. There are the results of simulation of MIMO OFDM over passband, and the results of simulation of entire transmission of LTE OFDM, and the results of optimal adaptive resource allocation. Firstly, this is the simulation result over passband in OFDM, and this is the constellation diagram over passband in OFDM, which is based on the QPSK, which is the same as QK 4QAM. Next is the relationship between the signal to noise ratio and the bit error rating. When SNR increases, the BER will decrease, and I get 5 points from the SNR, and these are the 5 corresponding values of BER. Next, I talk about the simulation results of LTE OFDM. I took two kinds of experiment. One is random data, and the other one is the image data. Firstly, I talk about the random data. The first image shows the time and the frequency domain of random data generation, and the second image shows the time and the frequency response on the 16 QAM. This is the time response of TX and RX data bits at SNR is equal to 10 dB, and comparing the TX and RX bits. And the second image is the SNR, the relationship between the SNR and the BER. On the random data, it can be seen that when the values of simulated and theoretical SNR are the same, the corresponding BER values of simulated is higher than the theoretical value. When the system requires low BER, high SNR is needed. This is the simulation result of LTE OFDM on image data. This is the input image data and the output image data. It seems the output image is quite the same as input data, so the transmission performance is quite good. This is the time response of TX and RX data bits when SNR is 10 dB on the image data, and comparing TX and RX bits. And this is SNR and the a relationship between SNR and BER on image data. Similar to image of SNR, first use BER on previous slide. This image. The simulated value is close to the theoretical value. When BER needed to be low, the SNR needed to be high. This is the performance of optimal adaptive resource allocation on multi-user OFDM system. This is the image of minimum users capacity versus number of users. Both the proposed method and the method in paper 2. Paper 2 is this is the paper 2. Paper 2 shows better performance than TDMA. The proposed method gets more minimum capacity than the paper 2 method. When numbers of users increases, the exceeding gain percentage between proposed and the paper 2 method will be larger and larger, because the interval between the proposed method and the paper 2 method is about 0.08 bits per second per hertz. And when the number of users increase, the interval will not change. So the exceeding gain percentage will become larger and larger when number of users increases. This is the ergodic sound capacity versus various sets. The sound capacity based on paper 1, the black curve, is the largest because the principle of algorithm paper 1 is to assign allocation to the user who has the largest channel gain. Other methods, some capacity are roughly stable, but the sound capacity based on proposed method is various based on the lecture constraints. With the increasing of set index, the corresponding sound of capacity increase in general. This is image of normalized capacity sound distribution among users. Comparing to the ideal distribution, the normalized sound capacity based on proposed method is quite rare. The result based on paper 1 shows that the sound capacity is almost on user 1, which results to other users have very little capacity. Now, I show the demonstration of a MATLAB program. First is the passband simulation. So this is a constellation diagram of passband simulation. And I'll show the relationship between SNR and BER. Now I get the result. Next is the simulation of LTE OFDM system. First, I need to select the one for random data and 0 for AWGN channel. You can also select for the Rayleigh channel. Time response image. This is a time response under the 16 QAM modulated, and the output of IFFT, time response of the cyclic prefix, time response of upsampling through the TX filter, analog output of filter, and demodulated signal, frequency response before X filter, and the relationship between SNR and BER. These images show the procedures like these procedures. All of the images show the procedures. Next, I select 2 for the image data and also AWGN channel. This is the input image data and time response, IFFT, time response of cyclic prefix, upsampling, TX filter, analog output of filter, demodulated. And the relationship between SNR and BER. And this is the output image data. Next, I show the simulation results of optimal adaptive resource allocation. So this image shows my evaluation, like this image. And because there are some sets, so there are some images. And this is corresponding to this image. And this is the image of this evaluation. So this is all of this is my MATLAB program. Finally, I can know the transmission procedures in MIMO and LTE OFDM system, and simulating the process of OFDM system. And I can achieve the optimal adaptive resource allocation and compare to other methods. And I can get the performance results and compare them among various methods. Thank you. That's the end of my presentation of project. Thank you for your watching.